All right, we are going to talk about section 7.5, which is solving trigonometric equations. Okay, so let's start with this one. Let's just think about this. Find all possible exact solutions for the equation cosine of theta equals 1/2. Okay, so what is this even asking? We're asking what angles could theta be that are going to give us this exact answer, 1/2. So let's just think about this graphically for 1 minute. All right, so the cosine graph is going to look like this, right, and go on forever. And if this is 1/2, what are we expecting? So like here's 2 pi. So just between 0 and 2 pi, how many values would we expect for theta? Well, here's 1, right? We'd expect whatever that value is, and we'd expect this value, and then those are going to go on forever, right? So there's going to be an infinite number of solutions if we just, for all values. There's going to be 2 solutions between 0 and 2 pi. Okay, so now we kind of know what we're expecting. So let's think what our actual values are going to be. So cosine of theta equals 1/2. So we have to think back to our table, right? What is this value? Well, cosine is 1/2 at pi thirds, right? So if theta equals pi thirds, so this value here is pi thirds. All right, we can get that from our table. How can we get this second value? That's not on our table because our table doesn't extend all the way to 2 pi, right? We can also think about this on the unit circle. So of course we're thinking if cosine is 1/2, right, there's pi thirds, and here's 1/2. We're looking for where the x value of an angle is 1/2. So the other one is going to be over here in quadrant 4, right? And the reference angle is going to be pi thirds. So the other solution is going to be 2 pi minus pi thirds, or 5 pi thirds, right? Those would be the 2 solutions on the unit circle, and so this over here would be 5 pi thirds. And now, cosine has a period of 2 pi, so we're going to take this stamp and go on forever. So we can write this as plus or minus 2 pi times k. We can say plus or minus 2 pi times k, where k is, any integer value. So we're going to get an infinite number of solutions on the whole number line. If we were just looking between 0 and 2 pi, we would have these 2 solutions here. And we can think about that using this graph or using the unit circle, right? Okay, let's do another one. We're going to do a lot of examples here. Let's fold this down. Oops. All right, find all possible exact solutions for sine of t equals 1/2. All right, so very similar question. So let's just think graphically. Sine is going to, go like this. So between 0 and 2 pi, we're expecting 2 solutions, right? And obviously for everywhere, we're expecting infinitely many solutions. And on the unit circle here, here's 1/2. So there's 1 solution, right? And let's see, what is that? If sine is 1/2, that's at pi 6, right? So 1 solution is going to be that t, I guess our variable here is t, that t equals pi over 6, right? And the other solution is going to be over here, right? So this looks like problems you had on your last test, right? If you have one, what's the other solution between 0 and 2 pi, where sine would have that same value? Okay, well, it's going to be pi minus pi 6, or 5 pi 6. Right, those are going to be our 2 solutions between 0 and 2 pi, and then we can say plus or minus 2 pi times k for all the solutions on the number line, right? Okay, let's do another one. What if we have an equation that's not so simple? Solve this equation. All right, well, let's make it look more simple, right? So just like we do with normal equations, if we could isolate the expression with the variable and move everything else to the other side, then it's going to be a lot easier to see what we need to do. And notice for this one, they've restricted the domain. They just want to know the theta values between 0 and 2 pi that would make this true. Okay, so first let's do some algebra. And maybe I'll add +3 to both sides. So I get a -2 there. And now let's divide both sides by 2. So cosine of theta equals -1. So the question is, where is cosine of theta equal -1? So thinking about, our cosine graph, there's just going to be one value here, right? What are we expecting? We're expecting one value where cosine is -1/2. Or if we thought about the unit circle, where is cosine going to be negative? So cosine is our x value. So sorry, over here, right? That's the only place that's going to be -1/2. So that's going to happen. We can see in both places at pi. So we say, okay, well, theta equals pi. And they're just asking from 0 to 2 pi. So that's our only solution, right, at pi. Okay, let's keep going. Let's do another one. Example 4. Solve this problem exactly. 2 sine squared theta -1 equals 0. Ooh, so now we've got a squared. Okay, so it's going to make things a little bit more interesting with pluses and minuses. So just like before, let's algebraically simplify this. So we've just got sine on one side and some numbers on the other, and we'll come back to this restricted domain at the end. So we could say 2 sine squared theta equals 1, right? If we just add 1 to both sides, let's divide by 2. So we get sine squared of theta equals 1/2. Okay, let's take the square root of both sides. So we get sine of theta equals, since we took the square root, we have to say plus or minus, right? Anytime we take the square root, we have to take both solutions. So plus or minus, and I'm going to write this as 1 over the square root of 2, right? And then I'm going to rationalize that. So I'm going to get plus or minus the square root of 2 over 2, so that this looks like something in our table. Okay, so now we have two questions. One is, where is sine of theta equal to positive square root of 2 over 2? And where is it equal to negative square root of 2 over 2? And it's, at least at the first, it's probably a good idea to separate those two equations out, just because they're really two different questions, right? So where is sine of theta equal positive 2 over 2? Well, that means that would be where theta equals pi fourths. And negative square root of 2 over 2 is going to be where theta equals negative pi fourths. So you will notice something that will be very helpful to you is your table. Okay, I have this actually set just out of view, so I'm kind of cheating. Kind of, but this is a lot of numbers to keep track of in your head and have to sort through every time, right? I think we could all, once we know this table, we could figure it out every time, but why, right? So you got to take this quiz. On the test, you're going to have this as a reference, right? So this is going to be the first question on the test. So you're going to have this to refer to. But this is one of the reasons why that's really important to know, right? So that when we have questions like this, it's not that hard to figure out, right? So if theta is pi fourths or negative pi fourths, it's going to satisfy this equation. And on our restricted domain between 0 and 2 pi, okay, so we're not quite there, right? This is pi fourths, and this is negative pi fourths. This is in the right domain. So here's one of our solutions. But here we're going to need to add 2 pi, right? So let's see, what's this plus 2 pi? Negative pi plus 8 pi over 4 is going to be 7 pi fourths. So this would be the second angle on that interval. Okay. All right. Oh. I missed some here. So let's look. Yeah, okay, so we got to be really careful here. So let's think about this. So between 0 and 2 pi, sine of theta looks like this, right? So these are going to be our two main answers. But for each of these, so if theta equals pi fourths, that's going to give us this answer. But now we need to also find this one, right? And this 7 pi fourths is going to give us, for negative square root of 2 over 2, it's going to give us this answer, but now we also need to find that one, okay? So in addition to this one, pi fourths, now we're also going to have to find pi minus pi fourths, which will be 3 pi fourths. And so our original one was this, we found this one, this second one. So here's another answer. And 7 pi fourths gave us this answer, because think about how it goes. It was a here plus 2 pi is going to be this answer. How are we going to find this? Well, it's a little bit tricky. 7 pi fourths is 1/4 from over here, right? So we're going to have to add pi plus pi fourths to get 5 pi fourths. So, see, I took a shortcut here, and it almost burned me, right? It's always a good idea to draw a sign graph, or just think graphically, okay, what's going on here, and how many solutions am I expecting, right? Because I almost forgot to find the second answers, right? This is our first answer, which we can get from our table. Here's our second answer. Here's our first answer, and here's our second answer. So also note that if you were to use your calculator, which we'll do in just a minute, to find these answers, to find these solutions, your calculator is going to give you the solution on the restricted domain for the inverse trig function, right? So it's going to give you the solution on this restricted domain, and then you always your calculator will never help you, will never tell you this answer. It might assist you, but you have to do the thinking to figure out, aha, yes, I need a second answer here. Okay, so there are 4 solutions to this equation. Okay. All right, let's do another one. All right, what if we don't have just sines and cosines? What if we have like things like cosecants? Okay, so if we have cosecant of theta equals -2, I'm going to write that as 1 over sine theta equals -2. So that's the way we do it. We always write things in terms of sine and cosine for the inverse trig functions. Okay, so then I can write sine theta equals -1/2, right? All right, and this is just, so now I want all the solutions between 0 and 4 pi. So where is sine of theta equal -1/2? So let's think of this as the unit circle. Here's -1/2. So my easy solution is going to be here, right? Sine of -1/2 off of our sheet is going to be that theta equals -pi6. Okay, my other solution is going to be over here. So so this is pi6. This is going to be 7 pi6. So those are my two solutions, but this one isn't between 0 and 4 pi, right? Or 0 and 4 pi. So I'm going to have to add 2 pi to this one. So that's going to give me 13 pi over 6. No, 11 pi over 6. 11 pi over 6 is this in the positive direction, right? 11 pi over 6, there's 7 pi over 6. So those are my two solutions between 0 and 2 pi, but this asks me between 0 and 4 pi. So I need to add 2 pi again for my second set of solutions. So let's see, plus 12 is going to be 23 pi over 6. And if I add 12 pi over 6, it's going to be 19 pi over 6. Those are the additional solutions because they told me to go between 0 and 4 pi. It's a little bit arbitrary for them to tell you to go between 0 and 4 pi, but they did. So we comply. All right, let's do another one. What about this one? Okay, this is getting tricky because we don't just have a normal angle here. We've got some funny business going on, like right, it's shifted. All right, here's what we'll do. Let's pretend that's not happening. And let's just say, okay, I'm going to let alpha equal theta minus pi halves, okay? And I'm just going to write this as tangent of alpha equals 1, okay? I'm ignoring the situation. I'm masking the situation. All right, so now I say, okay, well, what values are going to make this true? Tangent of alpha equals 1. Well, tangent of alpha equals 1 if alpha equals pi fourths, right? Tangent of pi fourths equals 1. Okay, now I'm back into reality, and I'm going to say, well, okay, alpha is pi fourths equals theta minus pi halves. So now I can solve for theta, right? Theta is going to be add pi halves to both sides, which is going to be 3 pi fourths. Okay, so we skipped the important part again. Let's think about that. What are we expecting here? What does tangent look like? So let's just remember, tangent, what's the graph of tangent look like? So it goes from pi halves to negative pi halves. It has period pi. And so this is pi halves, and this is 3 pi halves. And then it keeps going, right? Okay, so, and actually here's 2 pi, and it looks like that. Oops. So between 0 and 2 pi, which is our restricted domain, how many answers are we expecting? Well, here's 1, let's just say. So we're expecting like 2 different answers. Okay, and we've got 1 answer, 3 pi fourths. And 3 pi fourths is here. Is it? Yeah. Is that the right answer? If this is fourths, yeah, 3 pi fourths. Why is this weird? Because this is, it's kind of complicated. If this was complicated to you, it's complicated to me too. 3 pi fourths is, so I'm expecting that at pi, because tangent of pi is here. So 3 pi fourths, I think, would be negative. That's interesting. Oh, because it shifted. It's shifted. Okay. Alpha is good. So because this is shifted, right? So 3 pi fourths is shifted to the right by pi halves. Okay. So this, here's one answer. 3 pi fourths. 3 pi fourths minus this is going to be this answer here. Okay. There's a lot going on here, guys. Sorry. Okay. So our first answer, theta, is 3 pi fourths. That's going to make this true. Okay. So tangent has a period of pi. So this is one solution on here. And we are going to add our second solution. We're going to add pi to that. So it's going to be 7 pi over 4. Okay. So this graph actually is going to be shifted. So this gives us an idea of how many solutions we want, but not where they're going to be, okay, because this is shifted. So it was good to get that idea that there's going to be 2 solutions, but we could graph this on like Desmos, or you can do this by hand to shift this to the right by pi halves, right? The whole thing, that means we're going from 0 to 2 pi, and this is going to be shifted to the right by pi halves, and so that's our first solution, and then our second one is going to be right there, 7 pi fourths. Okay. Okay, let's look at this one. Identify all exact solutions to this equation. All right, so notice, so now we have some algebra to do. This is tangent of x plus 3. It's not tangent of x plus 3, okay? So the first thing we need to do is just simplify this. And here equals 5 plus tangent x. So we've had a bunch of tangent x's. So just like always, we got to use algebra to simplify this as much as possible. So I'm going to get rid of that parenthesis. Right? I distributed this too. All right, so now I'm going to bring all the tangent x's over here and bring this over here. So I'm going to get tangent of x equals -1, right? If I subtract tangent x, subtract 6. Okay, cool. And they're asking for x between 0 and 2 pi. And tangent of x is -1 at -pi4. So x equals -pi4. There's our first solution. So we don't have any shifts or anything. So let's go back to our tangent graph. So here's pi, 2 pi. So let's see. We have our vertical asymptotes. Tangent looks like this. So between 0 and 2 pi, if this is -1, we're expecting 2 solutions. And the solution we found is this solution, not even in that range, right? So we're going to have to add pi and add 2 pi to get these 2 actual solutions. So plus pi is going to give me 3 pi4. And if I add 2 pi, again, I'll get 7 pi4. So those would be my 2 solutions in that range. Yep. All right, so what if, we're almost done with this section, but what if we have something like this? Use a calculator. It's going to be the same idea, but instead of our table, we're going to use our calculator. Solve this equation where theta is in radians. All right, so let's grab our calculators. So let's see, I'm going to make sure I'm in radian mode. And I'm going to say inverse sine. Can you see that? Let me put it in the light better. Okay, inverse sine of 0.8 gives me a solution. So that's one solution, but how many solutions am I expecting? Sine looks like this, 0.8 somewhere up here. So I'm expecting 2 solutions on the interval from 0 to 2 pi. This gives me one solution, right? 0.927, and it gives me this solution here, right? The solution my calculator gives me is always going to be on the restricted domain. Okay, so this is the same thing we just did using the table values, but now we have to say, okay, the second solution is going to be pi minus this thing is 2.21 radians. Okay, so my first solution is going to be theta equals 0.927 radians plus 2 pi, right, since they didn't give us a restricted domain. And my second solution is going to be 2.214 radians plus or minus 2 pi. There's all my solutions. Okay, so my calculator only gives me one. I have to do the thinking to get the second solution. Okay, what about this one? Secant equals -4. Okay, so I'm going to write this as 1 over cosine theta equals -4. So cosine of theta equals -1/4. That's not on my table. So where can I put this so you can see it best? There. All right, so I'm going to use my calculator here. So I'm going to say inverse cosine of -0.25. Right? Just put that, I mean, you could do as 1/4, whatever. All right, so that's going to give me my first solution. So between 0 and 2 pi, -1/4 is like down here. So that's going to give me that solution, right? Because here's my restricted domain. Now I have to find this solution. So my solution 1 is going to be, what did it say? 1.823 plus or minus 2 pi. How am I going to find this one? Okay, well, there's symmetry here. So if I find this distance, pi minus that, what pi minus this value, then I could add that value to pi, right? I want to find this distance here. So I'm going to say pi minus, let's see if I put it there, that's best. Pi minus this equals 1.3. So that's this distance here. So now I'm going to say pi plus that distance to give me my second set of solutions. That's going to be this second point. I find it a lot easier to just draw a graph and think through this every time than to like memorize equations like this pi minus this. And I think it's easier to think through it. Say, okay, I need to find this distance. That's going to be pi minus this value. Then I'm going to add that same distance to pi to get that value. Okay. All right. And let's end this section there. This is a lot. So you might want to rewatch it and work through the examples yourself and see if you can get the same answers.